So while we're waiting, can I just ask a few questions of the audience just to get an idea of who we're talking to? So who here's a broadcaster? And maybe ISPs, internet service providers, CDNs, content producers, this kind of content. So people running workflows, running infrastructures already. Have you already in the streaming space? Yeah, and looking to get into the streaming space. Okay, so just while I think I'll kick off. There's probably going to be people joining us, so we'll just have to start a little bit slowly. It's I've got two different times. I've got nearly 10 to on my watch and nearly 1:45 on my phone. So we'll just kick off anyway. So I'm Don Robinson. I'm one of the contributing editors of streaming media. I've been in the webcast space for about 15, 16 years. Did my first stream back in Ministry of Sound in '96. I've been quite passionate about the area and the technology for a long time. I also, when I'm not wearing my streaming media hat, I'm a director and co-founder of a company called Ideas, which Adrian's one of the other co-founders and directors. He'll introduce himself more fully in a moment. And over the years, given quite an in-depth, hands-on experience of streaming and streaming tech, I got involved in consulting for a lot of broadcasters and a lot of digital media companies going online. And we started to not just provide pure consultancy, but offer solutions and technologies to address some of those problems that our consulting clients were facing. So one of those was a company which you've probably heard of called Thomson Reuters. They came to us with a fairly tricky problem, which Simon's going to define a little bit more fully. And we helped them virtualize their environment. Yeah. And I think at that point it's best to hand the reins to Simon.
Thank you, Tom. So I'm Simon Ball. I'm actually a global head of operations, multimedia delivery and infrastructure at Thomson Reuters. Thomson Reuters is a very large company, provides intelligent information products to professional audiences, and obviously well known for its media division as well. But specifically, my business unit within Thomson Reuters is Multimedia Solutions. And what we do is we provide multimedia communication services to corporations, ranging from investor communications through to PR communications, sales and marketing, and even internal communications. We are actually a truly global provider. We have 6 major encoding centers in 6 different countries across 3 different continents, and 16 serviced operations centers with staff that support the product. So a large part of what we do is investor relations communications, as I said, and in the US there's actually a regulatory requirement to communicate your results presentations to everybody fairly and equally at the same time. And this is often facilitated by a webcast that follows a very consistent workflow of capture from a conference call, encode to Flash, Windows Media, and HLS for mobile, and send out to the desktop and allow corporations to put it on their website, therefore giving fair access. In Europe and Asia, it tends to be a best practice, but still a high volume of that particular, of webcasting. So as a consequence of this, we actually do tens of thousands of webcasts a year. And because they are investor relation orientated, they concentrate into 4 results periods throughout that year. And within those results periods, there's very high volumes, sometimes over 300 in one day. The dynamic, though, is a rainy Sunday in December, there would be no webcast at all going on. A Thursday in February or November, there could be 300 going on at the same time. And these webcasts are delivered to audiences in their thousands. So just I'm sure lots of you have seen or heard a webcast before. We're focusing on the audio use case here, so I just grabbed a couple this morning just to give you a sound bite of the type of thing that we're doing.
Hello,
this is
and
a very simple
with
communication.
Michael O'Neill, Chairman of the Board of Directors, and Michael Corbett,
So this
Chief
is captured
Executive
off
Officer,
an
Citigroup.
audio telephone
Today's call
line
will be
via
hosted
SIP
by Susan Kendall,
and sent
Head of
to,
City
a
Investor
cloud encoder.
Relations.
So before we developed this process of cloud encoding, how we did it before was via a combination of service vendors, which is conference call companies and CDNs that provided encoding services to give us the volume, and via our own regional encoding centers, guys sitting in front of encoders, kicking them off and manually capturing the audio from telephone devices and routing them to capture cards. Very hardware intensive and very specialized in its labor. So the motivations for change to move away from this system were, first and foremost, improve customer experience. And it's always first and foremost in any one of our business decisions. And we did that by improving the audio quality, by facilitating HLS for mobile, and in certain situations we didn't have Flash, and we incorporated Flash as well for Android and desktop, and the variety of browsers out there. But also very important in our use case was increase resiliency and business continuity. One of the things about a regulatory communication is it can't fail, it has to hit the intended audience. And so for resilience is a key factor in that. Another component, and a very important component, was global platform consolidation, which is not just technology but workflow as well. Earlier I said we had 6 encoding centers globally. These were evolved from a series of acquisitions via Thomson Financial through the last 10 years. So each one of those acquired companies had a different workflow, a different process, a different application, and a different technology stack as well. And the goal was to consolidate this onto a single global workflow using the same technology stack. And obviously, as a consequence of that, allowing the business to scale. So we set about looking at what is the best way of delivering against this very unique use case. A lot of telephone capture, highly elastic in its requirement, and need to be highly resilient, and obviously we wanted to improve the customer experience first and foremost. So we looked at a buy versus build. Was there software available that we could modify a small amount to deliver against this use case? And categorically, the answer to that was not for our workflow requirements. We couldn't find anything that fitted it. It needed too much customization to make it fit. So we knew that we had to actually build the application ourselves. Then we looked at how would be the best way of building a technical architecture that could deliver this. So we looked at virtualized private data centers. Could we optimize TIN and deliver against that? And obviously, we discovered that that was very, very expensive and required a huge capital outlay to deliver against the use case. And cloud technology had evolved to such an extent that we felt that we could build this application and put it into the cloud. So as part of our evaluation process, we also tested multiple cloud vendors, and Adrian will talk about that in a little bit more detail later. But the benefit of the cloud was also resilience and the fact that we could avoid lock-in by having a multiple vendor solution. So I love this drawing because it's the geek in me that it really appeals to. We architected the system to be entirely resilient throughout the whole path. Adrian will talk a little bit more detail about the encoding later. But the bottom line is we used 2 availability zones of 2 telephony providers routed through 2 CDN ingress points meeting at the player side. And at the player side, put in an ASX playlist cut for Windows Media and XML for Flash. So at any point in that signal flow path, if there was a drop in connection, it automatically failed over. Incorporated into that was obviously device detect, so that if it was a mobile, an iPad, or whatever, a desktop, you still had that same resiliency built in. But in order to spawn and control all of these encoders, we needed to create a user interface that allowed our operators to manage it. And the user interface needed to be slimline enough so it was a web service and not an application, but also simple enough that we could easily train and recruit personnel to run it. And we engaged a company called Arrays that delivered a user interface that helped spawn encoders and talked to our webcasting platform to schedule events, times, clients, names, dates, and all of the things that you would expect, and match streams to events. Here's a snapshot of the interface. Like I said, you dial in twice to each event. And we encountered a lot of challenges that we didn't previously anticipate. One of the challenges that was quite amusing was a low percentage, 1 or 2% of the telephony events would, for no discoverable reason, have silence on the line. It wasn't silence that was natural silence, it was silence that was created by a technical error at some point in the connection. And of course, silence doesn't show a disconnect. It's, from a technology perspective, it's still connected. So we needed to put into the system some silence detection that allowed an operator to be alerted to the fact that it was detected, and then be able to take action and check whether it was because of a natural event or because there was an error there. As part of the interface, it uses the flash scrubbing ability, so an operator who's connected via the web service using a headset can scrub back live as the event is happening and check the last point of audio that they went to. They could also scrub back and put an in point and an out point and publish it out. So as part of that workflow, they delivered a top and tail webcast for on-demand, created MP3, and FTP'd up to our servers so that we were ready for an on-demand or any post-event authoring that was required. So I kind of went through that quite quickly, but I'll hand over to Adrian. And
you're 10 seconds over. So.
Oh, it felt like it was quick. So I'll hand over to Adrian, and he'll go into some more detail about the cloud.
Thank you very much, Simon. So, yes, my name's Adrian Rowe. I'm one of the founders of Ideas, together with Dom, who made the introductions. And Ideas specializes in Ideas specializes in workflow construction, bespoke workflow construction, in the multimedia, broadcast, and finance sectors. So, in particular, we focus on building really lean, innovative, high-density solutions at a big scale. And by big scale, we don't mean 2 servers, 5 servers, 10 servers. We mean 300 servers, 2,000 servers type scale. And some of the tool set and methodologies that you would apply to a traditional workflow traditional technology stack just are not appropriate when you're trying to work at that scale. When you're trying to do something where you've got to manage 500 servers because they're all doing something different, the way you go about that is really fundamentally different from the way you go about, here's a camera, here's an encoder, here's a CDN, off you go. The other word I hope I say over and over and over again as part of this presentation is elastic, because there's a slide on it later, but I'll touch on it already, which is the cloud means all sorts of different things to different people. And for me, cloud as a value add means elastic. And I think we can kind of help visualize that a little bit later on as to what that means. One of the things Simon, I think, has also said repeatedly is the solution was there to improve customer experience. It was all about high availability. There can't be a single point of failure. If something goes wrong, stuff is going to go wrong. I don't want any of my customers to notice. And then again and again and again, whenever there was a design decision or a steer as part of the project as it evolved, it was a very, very simple metric that Thomson's applied, which is if I do it this way or that way, which way is ultimately better for customers. And so again, constructing a system from the ground up, the system was constructed from the ground up so that there were no single points of failure, and we can do things like live upgrades. I can bring a service up, I can add in HLS, but any conferences that are running will just continue to run. I have zero disruption as it's going out. So what were some of the challenges? Just sat, blank sheet of paper, okay, here's a workflow, we now need to go and do something virtual with this workflow, or we need to meet these new criteria for the workflow. the sort of fundamental thing that we had to concentrate on and focus on all the way through is that Thomson Reuters commits an enterprise-class service level agreement to its customers. And we were seeking to build a solution from commodity components. From, if I go and launch a cloud server, it doesn't really matter which provider you use, they're all slightly different, but if I go and launch a cloud server somewhere, no sane, large-scale cloud provider is going to give me an enterprise-level service level agreement on that. I might get 99%, I might get 99.5% or something like that, but nobody is going to give me 4 nines, 5 nines, whatever it is I might want to do to deliver that. So how can I deliver a solution to customers with an enterprise SLA based around it, where none of the bits of Lego itself that I have to construct that solution with come with a matching SLA? So it's one of the big challenges up front. I almost kind of didn't put it on here, and then I thought, actually, this is a streaming media presentation, I ought to. We needed to deliver to multiple formats, to multiple different clients, so that they could consume the product, the slides and the audio and so on, in a way that was convenient for them. And we obviously needed to make sure that we could deliver those formats to whoever, whenever, and so on. Actually, it was kind of a must-have more than a technical challenge. It was just something, okay, here's a requirement, off we go, we need to deliver that. But we need to do that at scale. I think Thomson Reuters and Ideas are one of the very few customers who've, and this was part of a stress test, not part of a live thing, have made Amazon go, I have no more capacity, not your account has no more capacity, I have no more capacity. And that was a screenshot that's going to stay in the annals somewhere. But how can I make this system really, really big? And how can I keep on doing it? And how can I do that in a way that I can support and manage and keep really lean? I can't afford to have, if I've got 1,000 servers running, I can't afford to have 50 people sitting there looking after them all, making it work, because that just doesn't fit with the economic model. All at the same time keeping this resilient. No single point of failure, no single point of failure, no single point of failure. Okay, so Simon kind of stole my thunder with his lovely Visio picture earlier. I'm not so much of a Visio person, but let's just go through a day in the life of a Thomson Reuters event. So typically, certainly in 99% of cases, we know about them well in advance. It's a call, an investor call or whatever that the enterprise is making. There are exceptions to that, and we can respond in about a minute or so to on-demand type events. But typically, we know about it well in advance. So we'll create a couple of servers on the cloud somewhere, and we'll talk about what that means later on, to fulfill that. We'll do that an hour beforehand, roughly, so that the call center operators at the various Thomson Reuters facilities can check everything's running nice and early. They can dial in. They can go through security with the call operator or the bank that's running the event. 99% again of all of these are manual authorization. So it'd be ever so nice to phone up the particular bridge, automatically send your security credentials and just have the whole thing automated. But actually, the workflow we're working with is very much, these are manual. You're dialing into a conference bridge or Citibank's bridge or something, and you talk to a human being. I'm Thomson Reuters, dialing in to facilitate this line, and they'll patch you through. So yes, we talked about two encoders. If I've got an event in the States, say, what I'll do is I'll create two encoders, one on the east coast of the US and another one on the west coast of the US. And I'll do that for a couple of reasons. One is I want them to be close, in inverted commas, to the end customer. I want to minimize latency on all of the channel and delivery as I go from A to B. So I want them to be as close as is practical to the event that they're running for me. At the same time, I don't want them to be too close, because I want to make sure that in some genuine sense an error at one, so if you have a data center go down, for example, that's highly, highly likely to be completely uncorrelated to there being an error at the other. So if we launch an event in Malaysia, we'd probably create a couple of servers in Singapore, we'd create a couple more or one in Singapore and one in Tokyo, for example. So they're close to the event, but we're still getting really good separation and really good independence of channels. We looked hard at what some of the challenges were with the workflow previously. So Simon said there was a lot of merger and acquisition activity. There were some, a number of different workflows that were delivering a similar product. And we're saying, well, when things go wrong, what goes wrong? And 95% of the time, when something went wrong, what went wrong was the phone line dropped. A lot of these calls are an edge case for all the telephony providers. So it's not that unusual to have a call that might last 4, 5, 6, 7 hours. That's in the 1% of 1% of 1% of the average duration of a typical phone line. So the kinds of things that happen is you'll get somewhere down the chain, and it tends to be a very long chain. You're talking to one provider who talks to another, who talks to another, who eventually gets to the right conference bridge. Someone goes along and says, oh, actually, this call must have been left off the hook accidentally, we'll drop it. If it doesn't happen this time, it might happen the next time, and so on and so forth. It's very, very difficult to get control over those kinds of things. So the first thing we did said, okay, that's the biggest challenge. How can we make it go away? And so when we talk to the telephony network, we use one provider as a gateway into the telephony network for one of the encoders. We use a completely independent one for the other encoder. But what we do is it's a bit like Ghostbusters or whatever. We kind of cross the beams. So we get the audio signal from one of them, and we'll deliver it from, to encoder 1, and we'll pass a copy of that into encoder 2. We'll take the audio signal from encoder 2, and we'll pass a copy of that to encoder 1. And then if any of the lines drop, we can detect that in about a 50th of a second or so. And what we do is say, okay, here you go, encoder 2, have my audio instead. And so now I can go in there, physically hang up a line, and none of Thomson's customers will even hear it happen. Because what will happen is they'll get swapped immediately through to the other line that we've held open on the other encoder. So we've taken something that used to cause dead air, and probably a couple of minutes of dead air because you've got manual security to go through. So by the time you had an operator realize, which would be a few seconds, dial in and go through security, you're going to have a significant period of dead air. It now is something you simply don't notice whatsoever. The system self-healing, what the hell do I mean by that? This comes back to, I'm trying to deliver an enterprise quality service level agreement built on commoditized SLAs. So if something goes wrong, you need to embrace it. You need to expect stuff to go wrong, and you need it to almost be part of your normal workflow. But when something does go wrong, I want to do something about it so that a minute or so later, I'm not only haven't caused a disruption to customers, but if a second independent error happens, I'm still back in a resilient state. And I'll talk a little bit about some of the examples of that and how we happened. And then last point, it's a very rare use case, but actually from 0 to here's a conference, you're live and broadcasting in multiple formats, with CDN connections across the world, we can do in about 70 seconds from it appearing somewhere in the workflow. So what I've talked about so far is a bit of a kind of a merry hell. I've got thousands of encoders all across the world doing some stuff. And what I need to do is make them do stuff in a coordinated way that I can control and keep lean and so on. And the way we delivered that is with a very, very lightweight management layer on top that itself only runs on 3 servers, and it could be actually my laptop would do it just fine in terms of load it requires. It's just I need 3 in order to be truly resilient, and those 3 are spread again across the globe so that I don't have any single point of failure. And they sit there and orchestrate everything that's going on. They go, okay, you can come up now, you can go away now, you can come up now, you can go away now. We use some interesting technology to do that we're very, very passionate about. It's on the next slide. It's a technology called Erlang. We'll come back to that. Called Erlang, which is exceptionally good at delivering high availability, massively distributed systems. I'm happy to talk about that afterwards. And then you'll get bored of it soon. How do I give an enterprise level SLA when actually the SLA I'm getting on my component parts of it's probably around a 99% level? How can I turn that into something that Citibank are happy to have their investor statement or their EGM or their AGM held against, where the CEO stood up, he's talking to everybody, he wants everybody in the world to, who needs access to that, to have access to that. And that's why you need all of the self-healing, the dual independent channels, and so on and so forth. And we were blessed early on. with an opportunity. I think rather famously, Amazon had a significant outage in its East Coast data center. This is, what, about 18 months, 2 years ago, something like that, and they lost an entire data center. In fact, they lost about 4 data centers all in the same area. And it made the news, and everybody said it was just a terrible thing. And people like Foursquare were down for 4 days or something like that. They had no service whatsoever they could deliver to customers because this data center had gone up in smoke. We didn't get a support call during that process because we had a whole bunch of servers running in US East when that happened. We also had a whole bunch of servers sat in US West. When all the ones in US East went up in a puff of smoke, which happened in the course of less than a second, we crossed the beams, and all of the audio streams started appearing from US West instead. The managers go, oh, hold on, boys, this is not looking too good. We've got a whole bunch of servers that don't exist anymore. I'm now in I've got single points of failure everywhere in my system. I'm going to go create some servers in, Tokyo's got some capacity, Dublin's got a few as well. And we created mirror servers for all of the other ones. And we were back in a fully resilient model about 70 seconds later. My phone didn't go, and probably more importantly, his phone didn't go, because none of the customers even noticed that half of the infrastructure that was delivering the service was taken out from underneath them while it was running. And so there's an absolute fundamental, if you're trying to deliver something on the cloud is not like an enterprise data center. If you start to think about, here's how I would traditionally do a solution, now here's how I'm going to do it on the cloud, you will almost certainly end in tears. Not a good way to go. I'm going to skip over this one. We also made sure that the system was well architected and layered and all the kind of stuff you're supposed to do when you build large-scale enterprise systems. It's worked quite well. There's an upgrade I'll talk about later where, again, we completely changed the infrastructure from one location to another and one operating system to another. And again, Thomson Reuters didn't actually even have to make a software upgrade or patch to account for that. So what did we learn from the experience? One of the things that took me by surprise is this top one, beware black boxes. So when we first implemented a virtualized solution, we did so on a Windows platform. We could virtualize that just fine. We had to write some device driver code to allow sort of audio feeds to be split and shared in perhaps slightly unusual ways for the workflow. But we were using off-the-shelf components to do our stack delivery. So we had a Windows Media component talking off, delivering the Windows Media stuff. We had Flash Media Live encoder doing the RTMP encoding and so on and so forth. And whenever anything went wrong, our experience, which it didn't very often at all, I'm glad to say, but when anything went wrong, our experience is we'd be handing audio to Flash Media Live encoder, and it wouldn't be arriving at Akamai or whatever as a CDN partner. And all we could see, we got no genuine visibility of what was going on as a result of that. And part of Ideas' capabilities, we have our own audio toolchain from the ground up. So we, using entirely our own code, can deliver Flash, HLS, RTMP, you name it, we can deliver it. And so we started to swap out some of these black box components for our own, and we had a number of benefits as a result of that. Part of the motivation for that was to move from a Windows platform to a Linux platform. And the Linux platform, they're all charged by the second on Amazon, and they charge you a lot less by the second or by the hour for Linux than they do for Windows. But that, again, wasn't the motivation. The motivation was, can we get customer pain points and make them go away? And because we started to inject our own tool chain where it had been third-party black boxes, if we got a drop connection from Akamai or something, what we saw was down at a network level, we had a drop connection from Akamai, so we knew at that point we perhaps needed to go get a new Akamai endpoint to publish to, or we just needed to retry, or we just needed to do whatever. Whereas before it was, here's some silence. And there was almost nothing we could do about it. So we got vastly better visibility of issue and vastly better ability to cope with those issues as they happened. It then had some other bonuses, allowed us to reduce the size of our instance. So again, lovely black box component. One of the things that allowed the call center operators in Thomson Reuters to connect to the voice chain and so on was an Adobe tool called Flash Phone Gateway. Flash Phone Gateway requires Flash Media Server. and a sort of standard-side application to do that, and it would join flash traffic into SIP traffic. That requires Flash Media Server and a third-party tool. It runs only on 64-bit instances with a minimum of 6 gig of RAM. The instances we now create, and that was one of, I would guess, 20 tools that we needed as part of the tool chain to deliver that. The entire instance, now that we're using entirely our own stack rather than third-party stacks, is about 80 meg. The whole thing, including operating system. And I can bring that up in next to no time. I can deploy incredibly quickly, moving it to a new distribution, moving it from there to there takes no time. And so we had some perhaps slightly unexpected gains from that as well. So what did we learn from this process? Perhaps predictably, one of the key things we learned is that cloud is an abused buzzword. I mean, I kind of knew this going in because I'd done quite a lot of cloud work beforehand, but it's divided by a common language. Yeah, you go and you talk to one cloud vendor, we would like some cloud stuff. And they go, oh, yes, that's cool, we do cloud stuff. But everybody has a different meaning. And one of the perhaps most common ways that cloud is talked about is I used to have my mail server sat underneath the box's desk, and it doesn't anymore. It now lives on the cloud. Well, no, it doesn't, actually. What you've done is you've taken a physical server and you've virtualized it. That's a really cool thing to do. It probably saves you money and skills and so on and so forth. But that's not cloud for me, that's virtualization. By all means, do it, but don't mistake that with a cloud project. Cloud, for me, is about elasticity. If you're not delivering elasticity with your cloud solution, your ability to scale up and your ability to scale down, then it's probably costing you more money than it needs to. The other thing that took us greatly by surprise is some of the people who misunderstand the word cloud are some of the world's biggest cloud providers. We had a very explicit multi-vendor policy, so we were using different phone providers, we were using every different provider. Anytime we had a provider, we had two. And so we worked with, what, half a dozen, maybe more, different cloud providers to try and make them part of this solution. And we would go up to all of them and we would say, what we need is the ability to have up to 1,000 servers concurrently. We want to be able to turn it up and down. And some of them said, oh, no, that's not us. And that was hats off to them. Yeah, much preferred those conversations. But 4 or 5 of them said, yeah, we can do that, not a problem whatsoever. And we say, okay, let's get an account. And so we'd get an account with them. And the first test we do is, okay, give me 50 servers, please. And the account would crash. And it would go, hold on. Yeah, we've asked for 50 servers. We were supposed to have 1,000. We asked for 50 and you said no. What's that all about? And it's kind of, you asked for 50 at once. What you can do is you can get up to 1,000, but typically our customers do that over the space of 2 years. You know, doing that over the space of 10 minutes, oh no, we're not so good at that. No, we'll come back and test it next week. And actually one vendor in particular, we worked with for a year. And they kept on saying, come back next week and do another test. And throughout that period, every time you stress them in terms of real elasticity, no servers 200, no servers 50, up and down, up and down, up and down, they just fell over in a big heap. And that took us by surprise. So actually, we ended up using one cloud vendor, which is Amazon. I think there's possibly a couple others who might be able to do the kind of stuff we now need. But certainly when we were doing this a couple of years ago, Amazon were the only people who came close to being able to deliver the elasticity we wanted. I won't dwell on these, but when you're trying to do a cost justification of a cloud project, it's a bit more complicated than you naively think. Guilty as charged. Okay, I'll move on because I'm ashamed. But when you're doing a cloud project, this one's really key. Be lean. Get lean, stay lean, stay lean. Every time you're going to put another component into your workflow or into your tool chain, really ask why. Yeah, can I get away without having that? Because some of the perhaps unexpected side effects of our going from beware black boxes to here's our own stuff, and we've gone from an image of 10 gig down to less than 100 meg. Really, it had some economic impacts. Those weren't the motivations. It was all, we delivered a better service to our customers repeatedly because of some of those choices. So get lean, stay really lean, be vicious about how you justify that stuff. Okay, so it's really, really hard. I wave a lot, I know, but it's really hard to try and get a feel for what elasticity means. So what I'm about to show you here is some, where's the mouse? There it is. A visualization, I think from May, of the number of servers we had running at Amazon. So there's a lot of stuff going on here. These guys here are our 2 Amazon accounts. It should have been 2 different vendors. That's what we hoped for, but we ended up using 2 different accounts. These cubes are the various different data centers or the availability zones that Amazon have. So here's US East, there's US West, there's Tokyo, there's Singapore, there's Dublin. And the spheres are us creating encoders, and then they hang around for however long they hang around for, and then they disappear again. Okay, so what you can see is here we're creating a whole bunch of servers in US West. There'll be a whole bunch of matching ones in US East for our resilience and failover. So if we create one server in one place, we'll create the matching servers in a different availability zone on the other. So yeah, West over on the left, East on the right, in terms of the ones we're doing. And occasionally I think you'll see some in Singapore, probably matched by some in Tokyo. You know, most of the business is in the US. And I kind of like this, this visualization because the time to get excited is now. This is the really cool bit of this demo because there are no servers running. Okay, when the exciting bit is when you've got a zillion spheres going up and down and it all looks kind of cool and funky. And that's great. I've got lots of servers in use and I've got lots of money coming because my customers are paying me to deliver a fantastic service to them. But when I'm actually making my money because it's a cloud solution is when there are no dots on there whatsoever. You know, that's where it's cheaper. If I know I've got to have 1,000 dots and keep them on the whole time, do it in your own data center. It's cheaper. But when what you have is load that's going to vary and go up and down and up and down and up and down, that's a great time to look at cloud. When you're not quite sure whether today I need 300 concurrent calls and next week I need 500 concurrent calls, use cloud. Those are all great use cases. If what I have is 1,000 things and I need to do it all the time, don't use cloud. Maybe use virtualization, but don't use cloud. Okay, cool. I will hand back to.
Thank you. So one of the things about this project that I always look back and feel proud or impressed by was the time to market. We went for a proof of concept in 2010 in May. There was a sense of urgency around delivering this for a variety of reasons. We got funding approval in August 2010. The full project started after specifications in October 2011, and we launched in September 2011. So a very quick time from proof of concept through to delivery, and part of that is because it's a cloud solution, so there's not the big overhead of infrastructure installation, etc. So with that, just to remind what we delivered for our customer base, we improved the quality, we improved the resiliency, we reduced the amount of issues, reduced our upfront capex, and ongoing, we have the ability very easily to dynamically scale to high volumes. And in consistent with our goal of standardization of all of our global webcasting centers and service teams, we delivered a single global tool and workflow that we were able to deliver from anywhere. So a web service, and it's a cloud encoder. So with that, I'd like to hand over to questions. And I'll go over to the top table.
So it's probably inappropriate for me to ask questions because Adrian at least is a colleague, but are there any questions from the floor? Yeah.
Question for Simon. The example that you gave and really what you've talked about mostly has been audio streaming. I wonder if there's any plan to move to video and to include video in this solution.
We actually do a lot of video streaming as well. This cloud application addressed this sort of very high elastic volume that we deal with. We do video not to such great volumes, but still considerable volumes in comparison to a regional webcasting company. Yes, we are already in the first phases of a production-ready system that uses a centralized transcoding data center. The intention would be to take that data center into the cloud in the future. The challenges with video from a workflow perspective, from a technology perspective, they're very, very similar indeed. I mean, it's encoding, whether it's video or audio, it doesn't really make much difference, you just need more processing power. But from a workflow perspective, the challenges are much higher because with video comes acquisition of signals from venues, comes monitoring of video quality, and all of the things that go with that. So the user interface workflow that we created to deliver our video solution requires a much higher skilled personnel and the whole process. So what we've actually done in our first stage is go from sort of the traditional video conferencing satellite or video fiber delivery into an encoding center, localized encoding and publishing to Akamai, to an MPEG transport stream delivery mechanism from venue, bypassing the video conferencing, straight to a data center transcode, and that transcode publishes out to a CDN provider. We still acquire content from venues in the traditional forms because that's what our customers require often. But yeah, we're in the process. The next stage will be in the future cloud, but as you would have, over the last 3 days, you would have seen there's still a high degree of uncertainty around, what is the next de facto encoding format? Where is it going to be? The challenge we have mostly is our customer base is invariably, we're B2B communication services. Our customer base is invariably on the enterprise. So we don't have, we have different challenges with bandwidth and compatibility, older versions, and we have to actually cater for the lowest common denominator. We still support Windows Media as a stream for all those enterprises with XP and IE8 still. And then the top end, HLS for iPads. We have this sort of variety of formats.
Can I just build on that a little bit as well, because actually the tool chain that's in existence there, ultimately we are actually delivering video on that. And the reason we did that is to allow us a lot of the tools for time syncing and slide integration and so on and so forth actually work off a video signal, not an audio signal. So technically speaking, the deliverable on all of those is in fact a video stream rather than an audio stream. It's a video stream that, the video bit's pretty dull. In terms of the tool chain, video is not the challenge. It's exactly what Simon was saying about your workflow, your skill requirements from the operators and so on and so forth. And again, Thomson's business case around that is much more static in terms of demand, because you're resource limited elsewhere. It's your ability to get the signal out of the venue and so on and so forth, as Simon was describing.
There's just time for one more question before we wrap up.
Hi, you very eloquently described audio resilience and how you get audio resilience. I wondered if there was any equivalent video resilience.
Yes, there is. There's the same playlist switchover that works on a disconnect. Everything's dual encoded, everything's dual published. The standard SLA for Akamai is you put two streams to a single publishing point if you want to deliver against their SLA. We do that on 4 different publishing points at Akamai. So yeah, the same resiliency is built in entirely. The lowest common denominator is an internet connection at a venue. And the best way of putting resilience in there is probably the least desirable way, which is don't use the internet connection from the venue. Use the internet connection for your MPEG transport, or if you're using satellite, it's a different question. But use a telephony connection for an audio backup. And if there is connectivity loss, you've always got an audio for your content, because our use case is much more geared towards live and live content always making it to the end viewer.
Okay, well, we are back, I think, unless my watch is still wrong, I think we're bang on 1:30 now, so if there's any further questions, do come up and talk to us. Thanks, guys. Thank you for coming. Look forward to seeing you later.
Did we?